Okay, so I'm going to do the 2016 number 2 on macro. And you got it in front of you, so I'm not going to write the question down. You can see that the assets are $200 for reserves. At least I'll write some of it down. So if this is assets and this is liability, the deposit was $2,000, right? And on the assets, the required reserve was 200, and the amount of money that could be loans was 1,800, and the reserve requirement was 10%. So the reserve requirement is 10% of this $2,000, and they have loaned out $1,800. So for A, what's the dollar value of what can be loaned out? It's zero because they have they already loaned everything out. B, Mr. Smith deposits $100 of cash. Calculate the maximum amount of new loans that they can now make. Again, these are questions you have to read really carefully because you can easily make one like you're like, okay, well, the reserve requirement's 10 and they've loaned out, but like read question, it says can now make. So if it's $100, right, and the reserve requirement's 10%, that means $90 can be loaned out and $10 has to go into required reserves. So for B, the answer is 90. C has two questions. All right, as a result of this deposit, calculate the maximum change over time in each one of these things. So we know the change in money supply essentially is also the change in loans because it's how much is being loaned out. And the change in the money supply is the excess reserves times the multiplier, right? And we know the reserve requirement is 10%, so multiplier it would be 10, and the initial excess is 90, so 90 times 10 is 900. To find the change in total deposits, that's the money that can be loaned out plus the required reserves. So that is deposit times the multiplier, and that's $100 times 10 or $1,000. And so that just means that of that $1,000, 900 of it would have been loaned out, and 100 of it would have been put in required reserves, which makes sense because it's 10% required reserve. What it also means is this is the amount of money that would be changing in the money supply, which is also for part D. So the money supply changes by $900 too, because the change in the money supply is excess reserves, which in this case is $90, times the multiplier, which in this case is 10. And then E, provide one reason why the actual change in money supply could be smaller. Obviously, the bank doesn't have to loan out this $90. They could loan out 50 of it. And if it was 50, then it'll be 50 times 10. Then it'll only be $500. Also, when people take a loan out, this is automatically assuming that all the money that goes into that is borrowed is put back into a different bank, and then that money is loaned out. So what if you borrow at that 100? You borrow $50, but you only put 25 back in the bank. Well, that means that not as much money can be loaned out, and that slows down the money supply. Both of those things happen all the time, right? I mean, they happen every minute of every day. So really all we can figure out is the maximum change. With the information we have now, you can use statistical regressions to figure out the likelihood of different people holding on to or banks not loaning things out and how that tends to change the money supply. Although that's still a shot in the dark, but the regressions are the best tool we have available. So that is how to do 2016 number 2.